Assalamualaikum. Good morning. Can you hear me? Boleh dengar tak?
Yes.
Boleh dengar? Henrita? Henrita bacakan soalan nombor 1.
Question 1A. Robots are widely used in industry for pick and place operations, in which a robot arm is required to move to a desired angle for loading and unloading. Figure Q question 1A 1 Roman shows a block diagram of a robotic arm system used to insert an electronic component into a printed circuit board PCB. For the open loop system, RS is an input desired arm angle and theta S is an output actual angle. The robot arm is required to move 2 radians to fulfill the task. Furthermore, in industry, the robot should have a fast response as this will provide a higher productivity. Figure Q.1A 2 Roman shows the time response of the robotic arm to a step input of 2 radians. 1 Roman. In control systems engineering, 3 important control objectives relate to stability, transient response, and steady state error. Discuss the performance of the robot arm in terms of the 3 objectives. Number 2, one approach to improve the performance of the robotic arm is by changing the control structure into a closed loop system. A. Propose a block diagram of a new control system. Label all the blocks and signals. B. Propose appropriate sensors required to implement the control system. C. What is the purpose of using input and output transducers? D. Propose a suitable controller to achieve the objectives. 3 Roman. It is an engineering approach that before a real-time installation and implementation of the proposed closed-loop controller, simulations based on the transfer function and state space models of the robotic arm are carried out using MATLAB. Give 2 advantages of carrying out simulation before the actual implementation.
Question 1A is basically a theory. Okay, is a compulsory. If you look at this format, is during the pandemic examinations, answer all questions. So Q1, Q2, Q3, Q4 is given one by one with different password. Okay, start at 9 a.m., finish at 1 p.m., including the break between one question to another questions. Okay, so it's a robot, and the figure is shown here, where you have a open loop control with motor to move the robot arm from one point to another point. The input is R and the output is theta, which is the positions. And the output is visualized using the graph, okay, robot arm versus time. Okay, this one similar like assignments that you submitted previously. Okay, so the question number 1 is three important control objective relate to stability, transient response, and steady state error. Discuss the performance of the robot in terms of the three objectives. So you have to see the open loop block diagram, and then observe the response at the graph given, and then discuss in the scope of stability, in the scope of transient response, and steady state error. Boleh? Boleh ba? Boleh? Tak dengar lah ada orang bisu ke apa eh? Hello?
Boleh, Prof.
Tak dengar lah. Okay, is it the robot stable or not stable? Stable, okay? Because the response is settled down at the final value 1.5 radian, okay? And stable and reach REACH at the final value 1.5 radian, okay? And then in terms of the transient, what is the comment in terms of the transient? Overshoot lah, am I right? Overshoot there, how many percent? So if you look at the response, maximum 2 kan? So maximum 2, meaning that berapa ni? Somebody help? Berapa?
33.3.
Overshoot there. And then settling time there. Settling time. Roughly about how many? Itu 2.5 seconds. Then input is 2 radian. Output final value at 1.5 radian. So the steady state error 2 minus 1.5, 0.5 radian steady state error. So desired to radian. Achieve desired, and then the measured 1.5. So position not achieved. Okay. Boleh? Boleh? Then since it's not achieved, so we have to propose a block diagram of a new control system. So label all the blocks and signals and propose appropriate sensors to implement the control system. What is the purpose of using the input and output transducers, and propose a suitable controller to achieve the objectives. Okay, so this is the desired. Input transducer, error. This is a controller. This is your motor. This is your robot arm. And the actual angle. Okay. And this one is the output transducer. So what is the appropriate sensors to measure positions? Hamizi, what is the appropriate sensor to measure positions? Datang.
Datang, Prof.
Ah.
Tak pasti, Prof.
Kan dah buat lab itu? Potentiometer. Okay. Potentiometer, so saya tak nak pakai kabel kacau ni. Potentiometer. Tahu tak potentiometer? Easy. Variable resistor, or encoder. So apa beza potentiometer and encoder? Zairi, Ilham?
Yes, Prof.
Analog digital.
Satu mahal, satu murah. Potentiometer murah, encoder mahal. Sebenarnya
Okay, Prof.
kau fikir jauh sangatlah. Okay. What is the purpose using an input and output transducer? Balkis. Purpose of
Yes,
using,
doctor.
what is the purpose of using input and output transducer?
To make it so that we can receive and give out data.
Tinggi sangat, Bang.
Sorry, doctor. I don't know. To convert physical measurement signal to electrical signal. Yeah.
Fizikalnya apa?
Physical macam
Yeah.
radiant to voltage.
Okay. Ni Bang. Controller? Controller apa? Propose. Okay. Propose lah.
Propose.
Cadangkan.
Apa soalannya, doktor?
Kenapa
Saya
debat?
tak faham.
Propose a suitable controller to achieve the objectives.
Input and output transducer.
Controller Bang. Bukan.
Oh, control. For position central.
P controller.
Oh, P control.
Proportional controller. PID controller. Proportional, integrate, and derivative controller. Intelligent controller. Using artificial intelligence controller. Robust controller. Etc. So ini kita belajar next semester lah. 3143. SEEE3133. Control System Design. Soalan nombor 3. Henrietta, bagilah cadangan. Give to advantage. Give to advantage of carrying out simulation before the actual implementation.
Can know the outcome through the simulation. We can save cost.
Save cost. Cost due to actual hardware is expensive. Okay. So simulate first. Okay. Number 2. Many analysis and studies can be carried out before hardware design. Okay. Number 3. Optimal controller parameter can be obtained via simulations. Okay. Boleh? Boleh, Anita? Tak datang?
Boleh, Prof. Can you hear me?
Herman? Benedict Herman?
Doktor.
Semalam ada test. Kau datang? Quiz.
Semalam tak sempat, Doktor.
Kau tak sihat? Sihat.
Tak sempat sampai rumah.
Okay, B. Bacakan B. Bacakan B. Tak ada? Hidayah, bacakan.
An open loop system for another robotic arm is shown in figure Q.1b, in which RS is an input, K is gain, and delta S is an output. I Roman, for a unit step 1 radian, determine the output expression in time domain delta t in terms of K and A. Roman 2, with K equal to 4 and A equal to 2, plot the output system response.
Kan awak? So ini adalah output, ini adalah input. Okay. Nampak tak apa yang saya tulis? Hidayah, nampak?
Nampak Doktor? Nampak Prof?
Nah, theta over R, Hidayah.
Awak. Wait. Okay.
Apa jap-japnya? Ish. Budak ni dah dekat exam kan, jap-jap lagi.
Okay.
It's cascaded kan? It's cascaded, am I right? Nah, cascaded multiply ni. R input, K is gain, theta is the output. For a unit step input 1 radian, determine the output expression in time domain theta t in terms of K and A. Sedap ya. Kan? So ni 1 over S lah kan? Because R over T is 1 radian. Kalau Laplace dapat 1 over S. Betul? Betul? Hidayah, betul?
Yes, Prof.
Okay. So dah dapat macam ni. Macam mana kita nak buat? Macam mana kita nak cari theta T? Aisyah Syahira. Cadangan?
Inverse Laplace.
Boleh?
Inverse Laplace.
Sebelum tu? Sebelum tu? Sebelum tu apa ya? Pakailah PF. PF apa?
Partial fraction.
Dah makan belum? Macam belum makan je.
Belum makan lagi.
Astaghfirullah. Nah, Syah tolong. A sama dengan Aisyah Syahira. Ya,
K over.
oh, ni suara emas. B, Syah, Syahira.
K over S.
Kena ziarah awak ya. Tak mau. Betul.
Negative K over E.
Okay, so dah dapat tu, masukkan ke dalam. Masukkan ke dalam. Masukkan ke dalam mana? Syah.
Equation.
Equation. Equation apa? K over A. B. Minus K over A. Okay. Lepas tu? Soleha? Using inverse Laplace? Soleha tak datang? Ada ni. Siti Aisyah Soleha. Hello. Tak datang. Awang?
Toilet, Prof.
Awang? Awang? Angku Izzat? Awang? Ha? Tak dengar, kuat sikit. Inverse Laplace? Okay.
K over A minus K over A exponential of negative A.
Dekat apa ni? Macam dekat Google. So K4 A dengan 2. Okay, kalau K4 A dengan 2 given A equal to 2, so theta. Dua eksponen minus 2t. Betul? Betul? Zero Elmi, betul? Zero. Tak datang Zero tak datang. Nurul Nabila?
Ya, Doktor.
Plotting? Macam mana? Naik.
Exponential.
Kalau dah susah. So in control system, it is desirable to have a system for pole far from the origin. Explain this statement by observing the effects of changing the value of E on the time response. Macam mana? Katalah E5. Let's say E equal to 5. Okay. And K still 4. So theta T become what? Theta T become what? Nur Najwa?
5 minus
4.
4 minus
Kan?
Sorry, 5 minus 5 exponent power of negative 5t. Kan?
Wait. K4 A5 4/5 kan?
Ah.
Betul. 4/5 exponent minus 5t. Okay. So the response will be much faster. Okay. So output response will be faster as exponent minus 5t converge to 0 faster. Okay. So by referring the output expressions, discuss why a pole on the right half plane of S plane is undesirable. Positive pole. Will I explain? With positive A, i.e. positive pole, okay, such as katalah theta of t is equal to 1 minus exponent 2t. Okay. So kalau kita lihat di sini dia menjadikan sistem unstable. Due to pole at right half plane. Okay. As exponent 2t term is increasing when t towards infinity. Okay. So dia akan jadi macam ini ya. Okay, membesar when t towards infinity. So this one is unstable. Oh, panjang soalan ni ya. Panjang soalan ni. Oh, awak nak jawab final exam ni. Macam boleh? Rita, agak-agak boleh jawab. Rita. Yang soalan ni.
Baca.
Baca.
The robotic arm subsystem is combined with another subsystems to generate a complete control system for the whole manufacturing plant. Connections of all these subsystems are shown in the block diagram in figure Q.1c. For the purpose of analysis, a single transfer function representing the manufacturing plant is required. Obtain the required single transfer function CS over RS.
Jangan buat. So apa yang kita buat adalah block diagram ni. Okay, kita pindahkan ni ke belakang. Okay, pick off point. Okay, so kalau kita pindahkan ke belakang apa jadi? Pindahkan ke belakang. Positif. R. So kita pindah belakang, dia akan jadi H2 over G4. Okay. So this G3, G4, H1, dan ada satu lagi yang panjang. Negatif. H3. Okay. Lepas tu apa kita buat? What next? Ashraf? Ashraf ada? Tak datang. Amir Farhan? Amir Farhan? Tak datang. Banyak tak datang ni. Fatihah?
Ya saya.
What next Fatihah? Macam baru bangun tidur je.
Oh tak. Ah,
Ya.
Parallel.
Astagfirullah. Oh ni. Arrow berlawan tu. Arrow berlawan. Ha? Dia berlawan. Itu aja dah sesat tu. Arrow sama, baru dia parallel. Now, the arrow is in a different directions. It should be positive feedback tu.
Okay. Betul.
Positive feedback. Faham? G1, G2, okay. Fatihah, what's inside the box?
G3 over G4.
G3,
G3,
G4,
G4, oh, G4 over G4.
1
1.
minus G3, G4, H1.
Okay.
Sebab dia positive feedback.
Okay.
Okey. Berserah dah. Kita berulang kaji lagi ni. Next. What next? Isma? Isma?
Ya ada.
Next.
Next.
Langkah seterusnya apa? Ini tidur ke apa? Kau mengikuti ke tidak?
Tak error betul.
Ha? Okay. Ni kau schedule kan?
Tak error.
multiply, lepas tu dia lepas multiply dia adalah negative feedback
Betul.
dengan yang ni, negative feedback.
Okay.
Kan? Artinya dia akan jadi apa? G2, G3, G4. G3, G4, P1 tambah G2, G3, P2. Okay. So, orang ni apa? Orang ni C. Okay. Then, ni dah senang lah. This one is just cascaded. Okay, and then feedback. Okay. So finally, you get the answer. Ini apa tu? Ada orang tidur. Okay, so that is question number 1. Next questions. 11:42. Okay, next question, Soleha.
Yes, Prof.
Okay.
Question 2A, explain the relationship between transfer function and mathematical model of a control system. Why mathematical modeling is important in control system? B, a quarter model of a bus passive suspension system is illustrated in figure Q.2b. The suspension system is responsible in providing steering ability and good road handling of the vehicle. Both spring K1 and damper FV1 are connected to the vehicle mass M1 and the suspension mass M2. Spring K2 and damper FV2 are connected to the tire and M2. An external force Ft is applied to the mass M1. Draw the free body diagram and derive the differential equation for a passive suspension system related to figure Q.2b. Given the value of mass, damping coefficient and spring constant as M1 equals to 10 kg, FV1 5 Newton per SM, K1 7 Newton per meter, M2 20 kg, FV2 5 Newton per SM, K2 50 Newton per meter. Assume all initial conditions are 0 and no root disturbance affecting the suspension system. Determine the following transfer function. A y1s over fs, b y2s over fs, c gs equals to y1s minus y2s over fs.
Okay. So 2A, explain the relationship between the transfer functions and mathematical model of a control system. What is the relationship? SU2A. Matur Zaki, boleh tak kamu mute ke mikrofon? Is there? Physical elements. And the physical element and this element are analyzed to make the governing equations. Okay. So that is the relationship. Why mathematical modeling is important in control system. So I think everybody knows about it, but to make it easy, mathematical model helps us for easy analysis of control system. And number two, big system can easily analyze using Laplace method. Okay. So the next one is the mass spring and damper. Okay, for both K1 and FB1. So this one, can you change to B1? So that easy. Are connected to the vehicles mass M1 and the suspension mass M2. Spring K2 and B2 damper, usually using B2, are connected to the tire and M2. External force F of T is applied to the mass M1 and gravitational effect is neglected, meaning that this one is a hanging system. So you can assume gravity effect is 0. So this one is B1, this one is B2. Okay. So don't use FB1 and FB2 because it's too complicated. Okay, make the analysis complicated. So as usual, you have to draw the free body diagram and derive the differential equations for the passive suspension system. Okay. So we draw for M1 first. Okay. So usually the F force is here, force, and then this one is B1, X2 dot, and this one is K1, X1, X2, sorry, K1, X2. And opposite is, we have 1, 2, 3, B1, X1 dot, K1, X1, and M1, X1 double dot. Okay. And for the free body diagram, mesh 2, okay, M2. So we have 2, x1 dot, and K1, x1. And we have 1, 2, 3, 4, 5. Okay, which is B1, x2 dot, x2 dot, K1, x2, K2, x2, and M2, x2. Okay. So from this free body diagram, you can create the differential equations. Okay. Okay, to be continued on Wednesday, 2 p.m. Okay, guys? Hello?
Okay, Prof.
Okay, Prof.
Okay, Doctor.
Tadi ada budak tidur dia berdengkur bunyi. Saya dah keluarkan dia dekat waiting room. Nama dia Fatur Zaki, tidur dalam. So boleh hari Wednesday This is the last week
Boleh, Prof.
Boleh, Prof.
Boleh, Prof.
Study week nak buat revision ke tidak? Study week. Next week.
Tak nak.
Ha? Apa dia? Syahira?
Saya prefer untuk tak.
Tidak,
Ya.
tidak mau diganggu seminggu. Oh. Kita jumpa kat mall nanti. Okay. So Wednesday is the last day. Okay. So I see you later, inshallah. Thank you very much.
Thank you, Prof.
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 Thank you, Prof.